Today we're going to talk about a new property in math. This one covers both multiplication and addition. It's called the distributive property. And I want to show you how it works using a picture. Now, if I had a rectangle, I know that the area of a rectangle is length times width. But what if my rectangle was split up into two pieces? Suppose those two pieces were made up of x and y. Well, the area of my rectangle is the length times the whole width. And the whole width is equal to x plus y. But if I look at the separate pieces of my triangle, or of my rectangle, this area here is length times x, and this area here is length times y. And so when I put those two together, they must be equal to the length times x plus y. And that's how our distributive property works. When I'm multiplying by a sum or a difference, I take and distribute the beginning factor to the other two pieces. This helps us simplify algebraic expressions that we may not be able to simplify otherwise. So let's start with some examples. 4 times y plus 3. In order to simplify, I want to distribute that 4 to the y and to the 3. How do we write 4 times y? Yep, just 4y. And what's 4 times 3? 12. Now the distributive property works on both sides. I could do it like y plus 7 times y. This isn't the best way to do it. We don't normally like to write it like this, but it is acceptable. So we distribute that y again to the y and the 7. What's y times y? Y squared. And y times 7? We write that as 7y. Make sense? So when we do this, we get what are called equivalent expressions. Negative 2 times x plus 7 is one expression. The equivalent expression would be what we get when we distribute. Negative 2 times x is negative 2x. Negative 2 times 7 is negative 14. These could be slightly more complicated terms if we wanted them to be. I could do 5 minus y times negative 3y. And when I distribute, I've got to look at everything. 5 times negative 3y, that's negative 15y. And negative 3y times negative y is going to be positive because I'm multiplying two negatives. 3 and y times y is y squared. Now, I want to point something out with these polynomials. When you have a negative out front, it's helpful to look at that as distributing through a negative 1, so that when I multiply, I can use my property of negative 1. So negative 1 times 2x is the opposite of 2x, which is negative 2x. And negative 1 times negative 11 is the opposite of negative 11, which is 11. You notice in each of these polynomials, I have multiple pieces separated by addition or subtraction. These are called terms. Every time I come across an addition or subtraction, I'm looking at a new term. So each of these has two terms. Now some terms have something in common, and we call them like terms. And like terms are any terms that have the same variables, and the variables have the same exponents. Gotta have both. Or, could be, no exponents at all. For instance, 3x and negative 6x are like terms because they both have an x. And those x have no exponents. And negative 4 and 2 are like terms because neither of them have any variables. So we can combine those like terms by first using our commutative property of addition to reorder things, and then simply adding coefficients. 3 and negative 6, negative 3x. Negative 4 and 2, negative 2. Now, I don't necessarily have to reorder if I keep my eye on which terms are alike. Those two terms are alike, and so I add their coefficients 3 and -6. These two terms are alike, and so I add the numbers together, -4 and 2. And I have the simplified version of that expression. So I started with 1, 2, 3, 4 terms, and my coefficients, that is the numbers that go with variables, are 3 and -6. And my constants, that's the numbers without variables, because if we remember that variables mean able to change, then constant is something that can't change. And my constants were -4 and 2. So part of your homework today will be combining like terms and also identifying those parts. So if we look at guided practice number 5 on page 97, it says -7y plus 8 minus 6y minus 13. So I want you to first identify the like terms, identify the coefficients, and identify the constants in the expression, and then I want you to simplify. Take a second, pause the video, come up with an answer. Okay, so first of all, the like terms are -7y and -6y, and also 8 and -13. These are my constants, and -7 and -6 are the coefficients. So all I have to do to combine them is add my like terms. What do I get when I add -7y and -6y? Well, they're both negative, so I keep their sign, and I add the numbers, -13y. With 8 and -13, they have different signs, so I subtract and take the sign of the bigger number. There's my simplified expression. We could also combine this with the distributive property. In example 4, you have 4 times n plus 9 minus 3 times 2 plus n. So the first thing we need to do is distribute each set. The 4 over the n plus 9 and the -3 over the 2 plus n. Make sure you take the negative with it because it's subtracting that whole thing. So 4 times n is 4n. 4 times 9 is 36. -3 times 2 is -6, and -3 times n is -3n. Then we identify our like terms, 4n and -3n, 36, -6, and we combine. When I add the n's up, I get a total of just one n, but I'm going to write n, because having an n there tells me that I have to have one of them. I don't need to write a 1. And when I combine the 36 and the -6, I get 30. There's my answer. The last example we're going to go over together today is example 5 in the book, a word problem. Your daily workout plan involves a total of 50 minutes of running and swimming. So let's write that. Running and swimming is 50 minutes. You burn 15 calories per minute running. 15 calories each minute running. And you burn 9 calories each minute swimming. Notice as I go through this problem, I'm writing down things that I think are going to be important to this problem. Let R be the number of minutes running. Got that. S be the number of minutes swimming. Nope, doesn't say that. So maybe I don't need this. Well, we'll see. Find the number of calories you burn if you're 15-minute workout if you run for 20 minutes. So let's start by setting up an equation. I want to know how many total calories I burn. Now I'm going to burn 15 every minute for running, and R is running. And I'm going to burn 9 calories every minute for swimming. But let's think about this. If I spend 50 minutes total exercising and R is spent running, what's left for swimming? Well, if we don't know an exact number, it's hard to figure out. But I know that if I knew how long I was running, I would take 50 minutes and subtract how many I was running. So I can put that in for the amount of time I spent swimming. Then I can simplify this equation by using my distributive property. 9 times 50 is 450. 9 times negative r is negative 9r. And I can add my like terms. And that gives me a new equation, c equals 6r plus 450. Then they want us to find the total number of calories if we run for 20 minutes. So we take and plug in 20 for the amount of time that we run. And we simplify. 6 times 20 is 120. And 120 plus 450 is 570 calories burned total. Now I want you to try this yourself. If your workout lasts 45 minutes, how many calories do you burn if you run for 20 minutes or 30 minutes? So take a few minutes, go back to this setup here, and tell me what you come up with if this becomes 45 minutes and you run for 20 minutes one day and 30 minutes the next day. So pause the video, give it a shot. Okay, so we're going to take out this 50 and call it 45, which is going to change this 50 over here too. Then when we come up with our equation, we have c equals 15r plus 9 times 45 minus r. When we distribute, we get 15r plus 405 minus 9r, and when we add like terms, we have a final equation of 6r plus 405. Now what we need to do is test that equation for the two values of running that we have. So one part was to see how many calories we burned if we ran for 20 minutes. So we check with 20. 6 times 20 is 120, and 120 plus 405 is 525. The other was to check with 30 minutes. So 6 times 30 is 180, and 180 plus 405 is 585. If you have any questions, feel free to ask, or you can go back and watch the video again. If you don't have any questions, feel free to go on to the homework.